We've learned 5 visual elements in last class. So let me remind you what we learned last class. So we learned line, shape and mass, light, and texture and pattern, and space as the visual elements last class. So I saw all of your discussions posting. So this is the last week's discussion. The Renaissance master Raphael used in this painting. He used a linear perspective, a 1-point linear perspective in this painting to compact lots of things in a one frame and to create the implied space like this. So that was the answer about this discussion. Okay, so this is vanishing point. Vanishing point. Oops. And this is 1-point linear perspective. So please remember what he used for this painting. So let me move on to the next elements now. Oh, and I saw all of your sketchbook projects, which are amazing. So I left my feedback for all of you. So please check my comment after the class. All right, so so today we are going to see the left 2 visual elements, color and time and motion. So this is a prism to see the light color. So science tells us that we cannot perceive color without light. So light consists of energy that travels in waves, much as water forms waves. So the distance between the peak of each wave of this energy is its wavelength, which is the term from physics that measures light. So if white or normal daylight passes through a prism, we see that it is composed of constituent colors of light, which have different wavelength. So based on that color, we can divide the colors in 3 ways. So the first one is primary color, and the second one is secondary color, and the last one is tertiary color. So the primary colors are yellow, blue, and red. So these are labeled with number 1. 1 second, someone is coming in. So these are labeled number 1 on the color pill. So they're called primary because they cannot be made by any mixture of other colors. And the secondary colors are green, orange, and violet. Oops. Good morning. So, good morning. So again, the secondary colors are green, yellow, green, orange, and violet. So these are labeled with the number 2. Each is made by combining 2 primary colors. For example, when you mix yellow and green, yellow and blue, the 2 primary colors, then you can make green, the secondary colors. And if you mix yellow and red, then you can make orange. So when you mix 2 primary colors, then you can create secondary colors. And the tertiary colors. So tertiary,
Professor,
yes.
are you sharing your screen?
Oh, you cannot see the screen? I'm sorry. Thank you for letting me know. All right. You can see the screen, right?
Yeah.
Yeah. And the tertiary color. So the tertiary colors are labeled number 3. And these are the product of a primary color and a secondary color. So for example, when you mix yellow, the primary color, and the green, the secondary color, then you can make yellow green. And or you can mix one blue, the primary color blue, and the secondary color violet, then you can create number 3, the tertiary color blue violet. So now let's talk about color properties. So any color has 3 properties: hue, value,
Good morning.
good morning, and saturation. So let's see what these are in detail. So hue is the name of color according to the categories of the color wheel. So like this, red, orange, yellow, green, and blue, like this. And the value refers to relative lightness or darkness of the color. So here's red. So the lightest color can be is the original color in the value. And when you go to the bottom, you will see the dark red color. So that is value. And the last one, saturation. So saturation is called also intensity. It refers to the relative purity of a color. So colors may be pure or saturated as they appear on the color wheel, or they may be dulled and softened to some degree. And there are 2 ways to see the colors by light and pigment. It's additive color and subtractive color. So additive color or RGB color, which means red, green, and blue. So it is a property of a color model that predicts the appearance of color made by a coincident component light with distinct color. So RGB color uses for the digital art, like or digital color, for example, like the colors on the computer screen or TV or smartphone. So these devices, the electronic devices are using this RGB color based on the light. And the subtractive color, it can be called CMYK color. So C means cyan and M means magenta. So this color is magenta, and the yellow, and the K means black. So it is kind of mixing you get if you illuminate colored filters with white light from behind, so as illustrated as left. So CMYK color uses for all kinds of printing. So like, book printing or magazine or t-shirt printing. So these are used for by the CMYK color. And now we are going to see optical effects of color. So there are two types of optical effects of color we are going to see. So first one is simultaneous contrast. And the next one is optical color mixture. So let's see how the colors create the effects based on this two ways.
Sorry, Professor, my internet went out.
Good morning. So let's see simultaneous contrast first. So when there are two colors side by side, these colors interact with one another and change our perception accordingly. So the most popular simultaneous contrast is complementary color. So this is the color wheel. So when you see this color wheel, there are opposite colors. So for example, yellow and violet. So the opposite side of colors, these are called complementary colors. So green and red, blue and orange, like that. So let me show you examples to use the complementary colors as simultaneous contrast. So these are Vincent van Gogh's paintings. He used simultaneous contrast for optical effects of color in these two paintings. So look at the left painting first, this one. So so which color did Vincent van Gogh use for this painting? Can you tell me?
Primary colors?
Yes, primary colors.
Yeah, primary.
Yeah, there is blue, right? And yellow. And the orange is the secondary color. So mostly he used orange and yellow and blue. So the orange and the blue color, these are the complementary colors. So by using complementary colors as simultaneous contrast, the image is stamped on the viewer's eyes. And how about this, the right one? So
Secondary.
Yeah, so what kind of color he used? Which
Green.
color? Green, yes, and then orange, yes. So the ceilings and the tabletops are greenish colors, and the rest of part are red and orange colors. So green and red are complementary colors each other. So this painting is also using the same effects of color. And let's see the next optical effects of color. So, the optical color mixture. So the colors can be mixed in light or pigment, but they can also be mixed by our eyes. So when small patches of different colors are close together, the eye may blend them to produce a new color. So pointillism, this is a kind of art movement, and the artists of the pointillism, they use this optical color mixture to show the optical effects of color. So for example, let's look at the these boxes. So the left box uses, it consists of the tiny red and blue dots, right, in this box. And in the right box, there are tons of red and yellow dots in it. So now let's look at these two boxes with your eyes half closed like this. And a little bit stay away from the screen. And can you see, now, which color, can you see? What kind of color you can see? Can you see? Can you see the color? Can you see the different colors in that box?
Yes.
Yes.
Yeah. What kind of color? What's the color?
Red and yellow, right?
So
Hmm?
For which one?
yeah,
Both
which
of,
one?
yeah, both of, both of them.
It's
So,
like lavender and
so how about the left one?
it's like a
It's supposed to
lavender.
make purple.
Purple, yes, yes. It seems like purple, right? Yeah, how about the right one?
Orange.
Orange, that's
Orange, yeah.
right. Yes, that's right. So that is optical color mixture by mixing colors in our eyes. All right. And 1 second, let me take a picture. So let me show you an example to use this optical color mixture effect in an actual work of art. So this is Georges Seurat's painting. When you see his painting closer, you can see there are no brush strokes. So, and it consists of tons of color dots. All the colors in this painting are made by optical color mixture, which means the green color made by mixture of other colors. So that technique is called pointillism. So Georges Seurat developed this technique in the modern era, 19th century, as a post-impressionist. So you can, so I posted this, I posted a video about this painting to show which colors he used to create, the green and the purple, all the colors in this painting. So please watch the video. It's in week 3.1, Visual Elements 2, after the class. Let's move on to the time and motion. So time and motion have always been linked to art. So during 20th century, time and motion truly took their places as elements of Western art. So through advances in science and technology, daily life became far more dynamic, and the nature of time and its relationship to space and the universe more a matter for thought. So to show the motion in a work of art, there is a type of implied motion like the others visual elements. So we do not actually see the motion happening in a work of art, but visual clues tell us that it is a key aspect of the work. So let's see the examples to use the implied motion. So this is a marble sculpture by Gian Lorenzo Bernini, who is a Baroque artist in 17th century. So there is no actual movement in this masterpiece. However, the figures' poses are so dynamic and theatrical, so we could feel we are in the middle of the action. So that is implied motion. And this is futurist artist Giacomo Bella's painting, Dynamism of a Dog on a Leash in 20th century. So the artist,
Sorry, I'm late. Sorry, excuse me.
morning. So the artist tried to record all the time and motion of the certain moment in one frame. So, we can see a dog and a person is walking from this painting. It looks kind of, hilarious. So that is implied motion. And artists also can communicate the idea of motion by creating an illusion of art. Artists create this illusion through visual tricks that deceive our eyes into believing there is motion as time passes, even though no actual motion occurs. So let me show you an example for this illusion of motion. So can you see the wave? Mm-hmm. It looks like, it's actually, moving in the, image, right?
Yeah.
Yeah. So this optical grows out of the natural psychological movement of the human eye. And the art that moves is called kinetic art. So all kinds of art forms, with any medium, but which is moving, then these are called kinetic art. So kinetic art, the kinetic, the word is from the Greek word kineto, means moving. And kinetic art is art from any medium that contains movement perceivable by the viewer or dependence on motion for its effect. So, so this is on kinetic art piece. So you can see this movable work of art in a video. So I posted this video in the Moodle room in week 3.1 visual elements 2. So please watch this video after this meeting. This is going to be really fun. So today we have a discussion. So everyone, please go to week 3 and go to week 3.1. So can you see this blue icon, the page icon?
Yes.
Yes. And don't forget to read the textbook. And please go to this blue page, week 3.1, individual elements 2. And I'm gonna post this recorded class video in this page. And then when you scroll down, all the way down, then you will see 2 video links. So one is the Georges Seurat's The Pointillism painting. So please watch this. And then you will see the kinetic art video link. So please watch this video as well. So watching all the videos in the Moodle room is very important because you're gonna see relative problems in the midterm. And let me go back to the week 3 page. So please go to discussion 3.1. Someone already posted. Okay, so this is today's topic. So how is color interpreted in different cultures? So the colors affects our behavior. What are some of the scientific aspects of color? So search for your favorite color and give us a short summary of the psychological aspects of your favorite color. So please reply to